All right. Hello, everyone. And look at this. Look at this. Look at this. This is beautiful. Here it is, my Nvidia Jetson Nano. Oh my goodness. That's so cool. So I was able to finally trying to set it down very gently, carefully, make sure no ESD or anything, right? Um, but yeah, so I finally got it to work. It took a long time because first off, I didn't realize that the micro SD card doesn't come included. So I was like, oh, okay, I have to go buy a micro SD card. So I went out, bought a micro SD card, but my MacBook doesn't allow, or it has no slots for a micro SD card. So I was like, okay. I looked at my desktop. My desktop also does not have a micro SD or just a normal SD, so then you could do the adapter, right? Couldn't do that either. So I was like, okay, fine. Let me try to find a different computer. So, but then that's kind of awkward if you're like, hey, can I use your computer and just like install Billenia Etcher and install this really large ISO file and just etch it onto this micro SD? But anyways, got it. Good. Put it in. Uh-oh, I don't have a cable, right? The display cable, which is native to this Nvidia device, doesn't fit to my monitor back there. So once again, I was able to find something and be able to log in, click the right settings, and get the OS all set up and happy. So now it is happy. So let me come here and I can show it. I can show it off. All right, so let's actually let me just come here and move this over a little bit. So we can do this one right here. So just SSH into Timothy at Jetson.local. So this is obviously I'm connecting it right now from USB-C to USB-C onto my MacBook. So they do their own auto negotiation. It's not I didn't I was trying to figure out, do I need to do like create a static IP address for both the Nvidia and my MacBook, but didn't need to do that, so that's kind of cool. I was able to just plug them in. They actually, wait, no, hold on. No, 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 no. I was wrong. The USB-C to USB-C method has a static IP address, but I don't even need to know about that because it like auto resolves a like nickname for itself. So then you can easily just do this like SSH, right? As you would normally do. And then normally you have to actually say like, okay, the name of the device at and then the IP address, right? But we don't need to do that because we can just like it's auto resolved. So yeah, awesome. If we press that, it will ask us for our password. So Jetson, there we go. And we are in. Here we go. Okay, so if I do, and I know that this is gonna fail, but watch this. If I do Olama run, and then no Olama found. Okay, so that's what we're gonna try to fix today. Um, yep. So we are able to log in. The other thing that I can do, I want to show this, right? Ping google.com, right? We do this. Yep, it is working, and I was able to configure the networking over. I was able to do it headless over the command line interface. I didn't show that because you have to kind of like you have to like type your password in plain text. So didn't put that part in the video, but anyways, I was able to get it, and I'm able to ping Google now. So what that means is we should be able to go and download libraries that we need. Okay, so let me. What do I want to do? Let me come here, right? And let's just tell it the situation that we are in. I have an Nvidia, or also maybe I should follow the like whatever developer guide. Nvidia developer, video. Oh, I said, yeah, Oren. Okay, Oren. I'm looking at the box. The box has the name right there. Okay. Anyways, Nvidia Oren. It's actually called Jetson Orin Nano Developer Kit, right? Developer Kit, yes. Oh my goodness. Go on. Yes, there we go. And now what do I want to do? Startup? Yeah, setup. Maybe let's see if they give any like libraries. I don't know if they do. Okay. Otherwise, we're just gonna go to Gemini and see what it has to say. All right. Next step. Is this just like setting up all? Yeah, I've already done all of this. What is next steps? Because there's a specific command that you can get like Olama and all of this. I forget what it is. It's like you have to run some script, and it's like, okay, awesome, great. We are going to Gemini. Okay, so I have an Nvidia Jetson Orin Nano Developer Kit. Also, have you guys noticed like oh, well, I'm not signed in. But okay, well, yeah, that would be a reason. But when I am signed in to Google Gemini, my conversation history is gone. I tried to like get it back, and I know that it's there because I can see it. Like if I look at my query history or whatever, I see that it still has the history, so I know it's not like lost or anything. But just like that's just gone. I'm like, I kind of want that. It's kind of helpful to be able to have that history, right? I like curating my things. But anyways, so okay, I have an Nvidia Jetson Orin Nano Developer Kit. Awesome. I just put the OS on it, okay, and am connected to it via SSH, okay. I enabled Wi-Fi, and now I want to start developing and running AI models. What are some options which I can do for this? Whatever. Let's see if I know that there's a specific like it's like a certain script .sh, right? And then piped to sh. It was something like that. I can't remember what it was. Ah, here it is. Here it is. Yes, this is the one that I was looking for. sh piped to sh. Yes. Here we go. Now there is something to this though. Like follow-up question number 1. I don't want to just like, by the way, yes, I do know that if you copy and paste this in, it's going to work, right? But I kind of want to know, like, we're trying to develop, we're trying to learn. So let's put this into here as a follow-up question. I have not seen this format of a because I haven't seen it where you pipe it to sh. I'm like, okay, so I'm downloading, right? Curl is an API request, right? FSSL. Not sure what that flag does, but anyways, going to olama.com. Okay, that makes sense, and I'm getting the installation sh script, but then I'm taking that script and then piping it over to sh, which I'm guessing sh. Let me actually check this. Let me see. What do I want to do? I want to cd into users bin, right? It's gonna be here. And then ls, and we should see sh. Should be a command, right? Okay, where is S though? T S S S U S H. Where is? Okay, so he. No. SSH. Yeah, that makes sense. Hold on. SH here. So yes, right. We are taking the arguments, right? We're taking the script, and then does it pass it as an argument to the executable, which lives in our user bin folder, right? And this is just an executable. So it's going to run this executable and then pass in the arguments of a script, which we downloaded from the internet. I think that's what's going on. I just want to confirm my understanding, right? I just want to make sure that I'm on the right track. I have not seen this format. Come on, before, but what I think is happening is that we are downloading a script from the internet, and then what is the FSSL flag, right? Like this. Then the pipe is taking that script and passing it as an argument to my sh, how would I say this? Executable, which lives inside of /user/bin. So I think that it would be like, so the equivalent would be sh and then the actual argument, my script.sh. Don't do that. Okay. Is this understanding correct? Okay. Let's just see. Making sure that we have our bearings right. Okay, so then run a model. Then we can do the Olama run. Okay, so then that should pull down the manifest for this 3.8 billion. The 8 gigabyte Aura Nano handles this well. The 4 gigabyte version might need a smaller one. Okay, let's just try it. Let's just do it, right? Now the second question is okay, so this gigabyte right here is that the memory, right? Okay, so the second question that I want to know is how do I tell if I am on the 4 gigabyte versus the what? 8 gigabyte? Yeah. What is the command? All right, so we're gonna see like what we actually have. Also, that would be kind of right. Like, what is the command on Linux to determine the hardware which you're running on? What are the commands in Linux to determine the hardware you are running on? Yeah. Okay, so then we can do the Olama. That's awesome. Nvidia has a dedicated AI lab for the Orin series focusing on generative AI. This is the modern way. Okay. To run stable diffusion, vision language models, okay, and chatbots. Interesting. So initially what I want to do with this is start writing just agents. So I want to write an orchestrator to be able to go in and interact with the LLM and be able to have a user interact with the orchestrator to interact with the LLM. That's kind of what I want to do, but it's always nice to have kind of a understanding of, okay, well, what are the other things that we might be interested in doing with this project, right? And so we have here like stable diffusion. Um, I've heard this word. I don't actually know what it is. Is that image generation? Okay. So I'm just what are we on? Follow-up question number 3. Okay. And we know chatbots. Okay, that's fine. Can you give some examples of what these are? Okay, awesome. So now what do we want to do? Tool, the Jetson tool container. They provide pre-built Docker containers optimized for your specific Jetson pack. That's another question that I'm gonna have. Do we have Docker? DOOOOO. Or I could have just done like Docker version or whatever. Okay, where is O? Here, Docker. We have Docker. Okay. Try this. Clone Jetson container. Okay. Why? It avoids dependency of trying to get PyTorch and CUDA libraries manually on ARM64. Okay. So I actually don't want to do computer vision right now. But let's just look at it and see what is available, right? AI Lab, and what is this? Generative AI. Okay, isn't that all AI, right? Generates some output. Okay, so that's actually going to be a follow-up question. You mentioned generative AI, but isn't that all AI? Because all AI generates an output. Or do you mean something specific? Okay. All right. So then it talks about, yeah, so it might be very generic. Here. Ooh, what is going on? And we want to, okay, so this is some kind of like, it's a container built by Nvidia to be able to, so we should be able to just open this in a new tab, untitled. Okay, awesome. Jetson container. So this is not actually, who is this? This is not produced by Nvidia, I think. Dusty Envy. How many like stars and 4.4K stars? Okay. So all right. 65 okay, so it's a legitimate one. I just wanted to make sure it wasn't like sending me to some weird place and I download a virus onto my device or something. Okay. So we're gonna read the next one, which was computer vision, but we're not actually gonna be doing that because that's not what we're doing as of right now. We might do it in the future. Probably will, but not right now. All right. So, if you want to do if you want to do real-time object detection or image classification, okay, interesting, using a USB or CSI camera. So we have USB ports here. I also see the like cam 0 and cam 1. So we have like camera connectivity. Start with the classic Jetson inference library, okay? You can run pre-trained models for DirectNet. Okay, so we can just do some like pre-built or pre-trained models to be able to identify whatever people and cars and cats and airplanes, whatever we want, right? And just, I'm guessing we have a video feed, and that video feed, and then we run this library or executable, right? And then it takes that video feed, processes it, and then generates an output, which is some kind of like, I don't know what it is. We would have to look into it, right? But that's my envisioning of what it is, right? If you're building your own models, we're not doing that right now. So I've done that. When I was in university, I was really curious about like how do neural nets actually work? So I built my own neural network. I trained it with the MNest data set, and then obviously using like what was it, the negative gradient to be able to uh, minimize the loss function, and then going and using back propagation to actually uh, adjust all of your nodes, right? So we've done that before. It was super interesting. I think I have a couple videos here on YouTube where I was playing around with that kind of stuff. But that's not what we're doing right now either. We're trying to be one step above in the abstraction. And now I want to really get into like how do AI models work? Like how do you set up the environment? How do you set up the context window? How do you set up the interaction with the LLM? That's what I want to understand. How does the user do a query, and then you process that query, let the LLM do logic processing, and then now be able to give it tools. How do you give it tools? How do you create those tools? That's what I want to get into. So, anyways, if you're building your own models, you shouldn't use standard library, or you shouldn't use standard pip install torch, okay? Because it won't be the GPU accelerated for okay, so it won't use the GPUs. How to install Nvidia? I remember when I was doing this at university, I had to do like something dot two CUDA or something because our GPU. So actually, the CEO, Jensen, he graduated from Oregon State University. So I I can say he is like my classmate, right? Separated in time, but we went to the same school, and also we did the same major, which is electrical engineering. So yeah, I think it's pretty cool. So he donated a bunch of GPUs to our university, and so when I was training my models, I was actually using the Nvidia GPUs. So I remember having to do that. You like had to take your, I forget what I forget what I was actually putting onto the GPU, but I remember you had to do like two CUDA and then two CPU to get it back. All right. So you NVIDIA provides specific wheel files. Okay, so we do it through wheels. Use the NVIDIA PyTorch for JSON or Jetson guide. Optimization. Always wrap your final models in TensorRT. This is NVIDIA's secret sauce. Speed up inference by 2 to 5 compared to raw PyTorch. Okay, so we need to just keep that in mind if we develop our own models. Okay, so I want to use comparison of options. Yeah, so Ollama is the one that I want to use, right? Chatting LLMs, fast setup. This is what we want. Jetson AI Lab. Not really. Not right now. Generative AI, vision learning models, stable diffusion. Inference is for robotics, camera, object detection. That would also be kind of cool if we were able to have our Nano operate almost like a robot, and then we could have it move around. That would be pretty cool. Custom model development. Okay. Anyways, none of this, none of this. Check the power mode. Oh, right. So there's different power modes. I left it on default. I definitely did not put it on the max one because I don't want it to be just burning through the system. I can wait. Okay, I'm not in a rush. This is for fun. This is a development. This is for learning. This is for having a good time, right? I don't need a rush. So I left it on the lower one, but we can see what power mode we're on. Okay, so I'm gonna just get back to okay. So we want to do this one. Sudo nvp model and then -m0. Okay. Might be in low power. Ooh, no, 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 no. This is not the one that I want to do. No, no, no. I thought it was to check. Okay. Ooh, good thing I looked at it before I pressed enter. Oh, that's literally the exact opposite of what I want. Good. Okay. Let's see. Number 5 is going to actually be how can I check my power mode? I actually or I won't want to prioritize longevity of my device. I don't exactly need super speed right now if it degrades longevity. Okay. Since you're on SSH, keeping a separate terminal open and run JTOP. Install it via. Okay, I know JTOP. Okay. So this is kind of like a way to monitor Nvidia's. I thought it was like HTOP or something. I thought it was HTOP. No, not stop. Is JTOP another version? Improved version. I'm guessing that it just builds on top of. Anyways, okay. Let's press our follow-up questions. We are ready. Let's go. Okay. The curl mystery, okay, I'm correct. This is a pipe to shell installation method. Fail fast on server errors, silent, hides progress. Okay, fine. Okay, silent, show error if fail. Okay, awesome. Show error location follows. Okay, follows a retract. Okay. And then downloads the text of your script and sends it to the SH via the pipe. The shell then executes every line of that text. It's exactly like running the SH and then the shell script, but without saving the file to your disk first. Got it. Okay, so that's what we're avoiding is using up disk space. So that makes sense now. Checking your RAM and hardware. If you see, okay, so free H. So I'm guessing the free memory. Let's just do that. -H. Okay. So we're on 8. Okay. Gives high level hardware. Let's just try that as well. What is this? Free is here. So total is this, used is awesome. Okay. 5 gigabytes of memory. Okay. Now let's do sudo l show short. Okay. Jetson. Woo. Okay. Okay. Interesting. Okay. Processors, memory. L1, L2, L3 cache. Okay. ARM, yeah, which makes sense because so this is like the CPU. Yeah, processor, right? Yeah, that makes sense. Okay. So the processor's L1 cache. Int Okay, this is kind of interesting. Like what what are all of these? What does this mean? Hardware path, device, class description. Okay. So cat, so we're gonna print out something from proc device tree model, tells you the exact name of the board, and I don't care. All right, so VLMs and Stable Diffusion examples. These represent the eyes and imagination of AI. So vision language models. So vision and then language models. That's kind of a weird thing, right? These models can see an image and talk about it. Oh, okay, I see. So it is image to text transcription. Okay, that makes sense. Example, you show it a picture of your desk via a camera and ask where are my keys. It responds next to your coffee mug. Oh, okay. There we go. That makes sense. Popular models are Lava, which is Large Language and Vision Assistant, or Moondream. Okay. Stable Diffusion is image generation. Got it. Okay. Uh, you can type an astronaut riding a horse on Mars, oil painting style, and the Jetson creates the actual image from scratch. Oh, pretty cool. We can do some image generation. That is really cool. All locally. Everything is local. Everything is local here, okay? Okay, so generative AI is like yes or no or probability. However, the industry uses the term generative AI specifically for models that create new or complex content, okay, that didn't exist before. So generative AI is just generating something which has not existed before. Okay, that makes sense. Like paragraphs of text, images, audios, rather than classification models. Okay, like whatever, K nearest neighbor, or the other type of like models which we could use, logistic regression, all of that stuff. Analogy, traditional AI is a judge. Is this a cat? Yes or no? Okay, we got that. Generative AI is an artist. Generative AI is the artist. It draws a cat in a tuxedo. Yes, that's what we want. We want the artist. Okay, power modes and longevity. The Jetson device are industrial grade and very hardy. Running them at max performance won't break them. Okay, but it will make them run hotter. I don't really care about heat, really. I have my fan. I just don't want it to be like, you know, cranking out and not throttling if it's too hot. Check mode. Okay. And then this is the set. So M is setting. 1 is 10 watts is the efficiency mode. Okay. 0 is max in, uses all. Okay. Let's check. Let's sudo and then M or NVP mode, and then what was the flag? Q. Okay. Go. Woo. MVP. There we go. Model. Okay, we are on 25 watts, which is not the lowest, right? Because it says 10 watts. But it's also not max. Okay, I think it's gonna be fine. Ensure that it's spinning, which, yes, it's the fan is spinning. Okay, so HTOP versus JTOP. HTOP is a general Linux tool for CPU and RAM. It's great, but is blind to Nvidia's hardware. Oh, okay, so it's an Nvidia specific tool to be able to monitor the what? The like hardware usages, right? It's like task manager almost. Okay. So GPU usage, the most important part of your board, yeah. Power consumption, fan speed, temperature, all of that. Okay. All right, so let's come back up here, and we have some things that we need to do now. We need to download that script, okay, this one here. And we are going to, can I paste? Okay, good. Good. Because on Linux you can't do that, but on the Mac you can just Control V or Command V. Okay, ready? 1, 2, 3. Please work. Go! Installing a llama. Okay. Oh, this might be a while. Okay. Actually, yeah. I should have done this while I was reading. Okay, so while that is having its fun, maybe I can even put this to like the side like this, so we can have some, we get the enjoyment of seeing it. It's still, hold on, let me make it a little bit. There we go. Now we get the enjoyment of watching it while we go and read more. Okay. So we're gonna do that, and then we're gonna do the llama 3.8. Oh wait, no, sorry, llama 3, and then 8 billion parameters. Got it. Okay. What else? Was there any other questions we really have? I lost it. The other thing that I was going to do is that command that showed the hardware. I wanted to ask what it was, like, what those fields actually meant. Darn. Okay, what was the command? And, okay, let's just do this. Let's just, while this is running, what are we at right now? 9, okay. So I want to say, like, what will be the output of this, and what information can I learn from it? Because I'm curious, like, okay, the L1 cache, the L2 cache, like, right? Like, oh, is it for each of the cores? Because we saw multiple ones, right? We saw multiple processors or CPUs. It could be each of the cores. I don't know how many cores this one has. Hey. Huh? Okay, go. All right. So is a standard Linux utility that probes your system files like proc to build a map of your hardware. Okay, interesting. So is proc. Okay, so this is going to be follow-up question number 1. Is /proc the way my Linux OS actually no, because devices, the like /dev folder is where devices are, right? Like the drivers are in lib. But I can't remember. But you have your drivers and your devices. Your devices are the like mapping to the actual hardware. The drivers are kind of like the wrapper to be able to communicate or like send commands there. So what is this proc? Okay. Okay, so I'm gonna actually try to change this a little bit. I'm gonna say, as to my understanding, devices are folders in Linux which have the actual connection to hardware. Okay. They live in dev, something like this. Folder. Okay. Then we have drivers, which I think live in lib? I don't know. This is how the OS actually interacts with the, oh my goodness, it is still going. Do we get like an error or something? Like what is this? Downloading Olama. Okay, Olama Linux for ARM 64 Jetpack. Okay. So what were we downloading before? The same thing? What? Why? Did it fail? I didn't see anything that said it failed. Just 100% then 0 and then Jetpack 6. Oh, okay. Well, there we go. Creating Olama user. Now before I actually, well, let's look at this. Let's dissect it. Let's understand what's going on here with these commands, and then we'll figure out, do we need to run this? Like, obviously I know that if I do like Olama run and then whatever llama 3 8 billion, if I were to press enter right now, it would pull the manifest down, right, from the internet, grab it, and then I would be able to use Olama. But I want to know, like, okay, do we need to use Docker, or can we just run it on the hardware itself? Like, what if we do it through Docker? I think that will mean I am able to pull images that are specifically custom to interact with the Nvidia Nano hardware. But if I just download the models, they're going to be living on my host, right? And then you do a mapping, like when you do the Docker, when you spin up the container, okay? Then you just mount the location where your LLM like models live to the container, and now your container, so it's not using extra memory. I'm trying to make sure that I decrease the memory because those models are going to be really huge. That's what I'm trying to think through. Okay, but we're not doing that right now. We are not doing that right now. Actually interacts with the hardware. But now we have this new character of proc who I have never heard of before. Okay, I like this a little bit better. Who is proc? What does it do? And can you tell? Or yeah, just like yeah, that's fine. All right. So let's see. We saw a lot more than this. We saw a lot more. Hardware path. Okay. So memory capacity, the 4 gigabyte versus 8 gigabyte question. Look at the 0, 1 path under class memory. Class memory here. Memory 8 gigabytes, SODIMM. Okay. Okay, so this I see. Okay. Now if it says this or similar, you have 4 gigabytes. If it says the 8 gigabytes, you have the 8 gigabyte model. Now, okay. Storage type and health. It will show if your operating system is running off of SD card, which it is right now. Usually listed under MMC block or an NVMe SSD. Okay, since the Orin Nano developer kit relies heavily on external storage for the OS, this confirms your drive is recognized correctly. Okay. Then our network interface, so like the Ethernets and the Wi-Fi's, that's normal. Yeah, I had to do troubleshooting for the network. I was trying to remember at the beginning of this video I said I thought that I needed to create a static IP address because I was trying to plug in the Ethernet connector and then using like a little dongle to be able to, where is that? Okay. I think it's in my backpack actually. But a little dongle to be able to go from Ethernet over to USB-C and then plugging that into my Mac. And I was trying to mess around with the IP addresses, and so yeah. Okay. CPU architecture. Well, LS or L shows the nodes or the node. It confirms you are on ARM64. Which is vital to know because standard x86 software will not run on this board. Okay. So I have a bunch of follow-up questions. Number 2 is I am seeing a whole bunch of, what would it be? CPUs and processor entries on this lshow command and L1, L2, L3 cache. Is this my meaning I am running on a what? On multiple cores. I'm assuming that that's what it means. And what do those entries tell me? It's kind of interesting to know these things just so that we're able to know that we have this tool when we, or if we, hopefully, let's say if, okay, let's be optimistic. If we run into a problem, it's like, oh, okay, I know that I have the ability to query the hardware. That's pretty helpful, right? Okay. It's great for physical map, but if you want specific details, these peers are often faster. So LSub, seeing what cameras or dongles are plugged into the USB ports. Oh, that actually might have been kind of helpful about a day ago when I was doing the troubleshooting, which I just mentioned. Okay, seeing internal GPU and NVMe connection. Okay. Seeing the number of cores and clock speed. Okay, okay, okay. And then free M, the quickest way to see exactly how much RAM is available. Okay, here we go. So now we're going to take a little bit of a pause from that, right? Very much like back and forth, back and forth, back and forth. We're all over the place right now. But, okay, creating Olama user. Okay, adding Olama user to render group. Adding Olama user to video group. Adding, okay. What are these user groups? That's going to be the first question, right? Copy you. And now we're going to go 3 here, and I will say, what are these user and groups? Okay. Question number 4. All right, so now creating Olama system D. Ooh, so we get to create a daemon. So we're doing creating the daemon service, right? Okay, and then enabling and starting the service. So that's going to be the system ctl enable Olama, right? That's going to be the command that it actually does. So we create the like dot service, like the daemon dot service. It's like a text file, right? And actually, I bet we could. I bet we could see that text file. I bet we can. We just need to know where to look. Can I type who? Which, and then can I user? Okay, so let's user bin systemd. What? Okay, hold up. ls and oh, we're back in bin. Okay. Now wait, so if this is like an executable, we want s, right? But where does it store? Where does systemd actually store things? Okay. Password agent, users, bridge, run. Are any of these looking helpful? Blue. Does that mean it's okay? What is the color coding on this actually? So here's system control, the one that I was just talking about, that does like the enabling of it. But I thought that this one was, like a folder. It might be. Systemd. I'm just going to try it. CD into, I have to be careful with that because I just realized those 2 letters right there, the C and then the D, when you say it out loud together fast, it sounds like the Apple Assistant. So the Apple Assistant wakes up and starts talking. I had one time where I said first letter, second letter, and then, right, because that command, you are trying to change directories into something. I was just talking to myself the way that I normally do when I'm making YouTube videos, and I said, where am I? Right? Just like trying to say, where am I? Because I was trying to figure out which file I wanted to go into or folder I wanted to go into. And the Apple Assistant was so kind enough to give my exact GPS coordinates. I was like, thank you. Thank you. Thank you. Okay, so we are doing system D. Let's see if we're able to even do this. Like, or are we just trying to change directories into a executable? We'll see. Go is not a direct. Okay, it's an executable. Okay, okay, fine. But then where does it store its like service files? Where does system D no store the x or the dot system or service, right? Files. Yeah, okay. Anyways, now we have so much junk there because we have to go back up. Oh, come on, come on, come on, come on, come on. Okay, there we go. There we go. Okay, so we are enabling and starting the daemon. Awesome. And then creating a link. Wait, hold on a sec. There we go. We are okay, awesome. So we are creating a link in etc systemd system. I knew it was systemd. I knew that there was a folder called systemd, and it was a folder. Okay, and then default target once, right? Olama service. So this is going to be olama.service. So this is going to be the file that we are actually interested in, right? Okay. Now symlink, does this which one is the actual location and which one is the like reference, the link one? I cannot remember. But I know what we're trying to do here is we are taking the .service file. So like this one, right? Let's say that this is the actual one. It's just gonna be like a text file or something. I know that we're taking it, and then we are creating a link within the systemd. I forget what is it like. Systemd, when it first boots up, it goes through and initializes all of the processes, right? So systemd, it's process number 1 or 0 or something. No, I think it's PID 1. But it starts up and then it creates all of the children processes, and then when something like when something dies, or if a child process dies, then the kernel sends a message up to systemd that say, hey, this process dies, and then systemd will go and look at the like service file and say, does it say like on or like reboot is equal to always or something like this. If it says reboot always, then it just reboots that service back up. Okay. But I can't remember which one is which. So okay. So Nvidia Jetpack is ready. Olama API is now available at here. So this is local, right? Okay. So that means what I can do here should be I can run Olama, and then I can ping myself to this IP address a command. Now, the easier way, obviously, is just going to be Olama run and then the model. Easy, and then from there you can do it. But where our ultimate goal is we are going to essentially be calling Olama very similar to an API from our Python, right? Because we're going to be creating the orchestrator. So I'm just trying to think through this of, okay, how are all of these pieces going to be fitting together. Install complete, run Olama from the command line. Okay, so now we should be able to come here. I am actually going to get rid of this one and paste it in here. For this command, which one is the actual file and which one is the link? Can you go over exactly how systemd will do what? Will initialize this upon startup? On startup. I want to approach this question from understanding how Linux actually operates. The purpose of this question is understanding and learning. So how does systemd actually go about starting up these processes? Starting up these processes. Okay, that's going to be this question, right? And now I should be able to do, get back to my actually, let's just go to desktop. Would it be desktop? Do I have a desktop? Yes. Okay. Okay. So let's ask these questions. And we can okay. Let's do question number 5. I now want to run an LLM on my device. Okay. I want to run should I use a Docker container or should I just do whatever Olama run llama 3 8 billion. I am thinking that I can do this one on my actual machine, and then later when I want to do what? When I want to do something which requires a specific Docker image which has been custom built for my Nvidia, then I can start up Docker container and mount the models which I have. Does this sound good, or do you see any potential issues with my plan? Okay. Go. 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 All right. So The mystery of proc. Right, right, right. Okay. So in Linux, everything is a file is a golden rule. Yep. Uh, the slash dev contains device nodes. These are the mailboxes for hardware, right? So you write to this. Susie is sending me a bunch of messages. She is, yeah, she's a little bit worried about something coming up. Um, but I think she'll do great. She's so smart. She's so smart. So, but anyways, after I'm done with this video, I'm gonna have to go and be like, "You can do it, 加油，加油，你好厉害，你特别的厉害。" OK，就是需要相信你自己，好吗？Everything is a file. Dev. Devices. These are the mailboxes. Okay, for hardware. So, I have this folder and I am sending data into it, right? Now, who is sending? It's going to be the wrapper. What is the? Oh, apparently my brain is not working right now. The drivers. There we go. The drivers are going to be the ones that actually send data to that device node folder, and and once you send data to that folder, that's mapped to the physical hardware somehow, right? I remember I looked into it because I was pretty curious. I was like, wait, how is this actually working? But that was a little while ago. I kind of forgot, but I remember there was something about like it's literally the 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 like registers are literally like connected to the physical hardware. It was so cool. I was like, "Oh, that's awesome. That is so cool." And then when you do like a write enable or whatever, it like flushes to the address. So you have the control line, or what was it? The control. I think it was a single like one single line, but then you have whatever your 8-bit or 16-bit or 32-bit or 64-bit, whatever it is, right? Data line, and then you have your address line. And so you put on the address which you want to write to. Yeah, so you put on the address that you want to write to, and then once the control line goes high, all of the data from the data line gets written to the destination, right? So it kind of like opens up based off of logic gates on the address side, or the target side, I guess you could say. Each target is kind of like a door, and the logic gates only one logic gate opens for a given address, right? And so whatever is written in the address, whatever the door is open at that time, the data gets just like written into that location, or like sent to a specific GPIO pin or whatever it is, right? Physical hardware. Anyways, we're kind of getting distracted. So, proc is not a real folder on your disk. It's a virtual file system created by the Linux kernel in RAM. Okay, so it's living in RAM. The purpose. It is a window into the brain of the kernel. When you cat this, which, by the way, we're about to cat something. We're about to cat that system file. Let's just do that. It told us the location where it was. Although I got too distracted and didn't actually write it down. Okay. What was it? Etc. I forget. Oh, here it is. Etc. System D. Okay, so we are going to go into etc. and system. There we go. And now we can go in here, right? And we should see something which is system, right? Yep. Okay. And now from here, okay, so here's where our services are actually. So here we see Olama service. So let's just do cat and then olama.service, right? And yeah, we have unit, service, and install. So by the way, do you guys remember when I said like, oh, if it says restart equals always? So if for whatever reason this Olama daemon like dies, okay, well then all of a sudden it's gonna start it back up. It being system D. So it's gonna look at it, system D. I need to be very like targeted with my language. System D is going to go in to look at this service file and say, okay, well, Olama just died. What should I do? Do I see something that says restart? Yes, I do. So I am going to restart it. And then the exec start. So this is like the location where our executable is going to be. So user local bin, right? Where another place where you can put executables, and it's called Olama. And apparently, I'm guessing that this is like an argument that you pass to the executable. Environment setting environment variables. Okay. Wanted by target. Okay. And then just metadata, kind of just like awesome. Okay, so I said that we were gonna do it. We did. We looked at it. Here's the Olama dot service file. Let's go back to our like home. Okay, so come here, and now proc, it is a virtual thing, and so the contents. Oh, getting hungry too. Okay. The contents. It contains information about the running processes. Each process gets a numbered folder and system hardware status. All right, so multi-core and caching. Yes, your Orin Nano has 6 ARM cores. Awesome. Each core can handle tasks independently. This L shows them so you can see if they are enabled. The L1, L2, L3 cache, this is ultra-fast RAM located physically inside the... but I'm kind of just wondering, like, I know that L1, L2, L3 cache is like really fast memory within the chip, but I want to know, like, what is it telling? Well, let's just look at the command again. Let's this one. Okay. So I think it just tells you how much memory or how big the L1 cache is, right? How many? It said 6. Where did I see that number? I thought it said 6. 6 ARM core. Yeah, so let's count them. Let's count them, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wait, no. These are all of the other caches. I thought I was like, I found something. Found something wrong. Okay, so... okay. I think this is just telling us how much memory we have in each of the hardware locations. Okay, fine. By the way, there's that MC block, right? Okay. Okay. Now, users and groups. Linux uses permissions. Oh, we're just changing permissions. That's what we're doing. User creates a service user named Olama. This means the AI software runs as its own person. So if it ever gets hacked, the hacker only has access to Olama files, not the whole system. Okay, whatever. On a Jetson, GPU is considered video and render device. By adding a Llama user to these groups, you are giving software permission slips. Okay, actually, that is kind of, I can foresee this being a roadblock in the future where I'm like, why am I unable to get access to certain hardware devices that I need? And this will be the problem, right? Or hopefully, this is kind of what we did was the solution. It added us to those user groups. Okay, so without these, AI would try to run on the CPU, which is very slow. Okay, cool. In your output file, this is the contain. Okay, so this contains the recipe of how to start the app. Okay, obviously I can tell that my brain is a little bit winding down for the day, right? I got off work today at let's see, so start work at whatever 8:15 in the morning, and then got off work at about 7 o'clock today, 7 p.m. But it was super productive. But then came home and now started this video. Messed a little bit with the getting the Wi-Fi and stuff on my Jetson, and then started this video. So yeah, I've been just going all day today, and it's almost 10 p.m. But I mean, it's awesome. This is awesome, but also my brain is, slowing down a little bit. Little bit. Okay, I'll probably need to get something to eat because I have not. Did it? I know I had a snack today, so that counts. That counts. The actual file. Here, this is the recipe on how to start the app. Okay, yep, that's what we saw. That's with the unit and the service and all that. It should be right up here. Yeah, unit and service and install. All right, the link, etc. here, but it doesn't really. Oh, here it says how systemd starts up. So the target, which means whatever this, I'm guessing. It reaches for a target, usually multi-user target. Okay, which means ready for work. The wanted systemd looks in once folder, the .once folder, which is here, associated with the target. So okay, this means that this will have links to all of the recipes, which is here. And in this recipe, there's the exec start, which launches the executable. And I'm guessing if we go and look at this, it's not going to be an SO file, right? Because SO files are shared object. Those are libraries. But this one will be like an ELF or something. So if we looked at the Olama source code that generated the executable, it should have something which is like you can run it in the background or run it in the in the foreground, and which would just be like forking, right? You would do a fork and then return if you're the parent. So if you're the parent, you return, the child is still going and doing the process. So that would be in the background. But if I do something like from my command line, olama run, that should be in the foreground. So it's not going to exit as the parent. It's just going to go and run it in that process that started it. But here it should be in the background. Okay. Systemd reads the recipe, checks if the network is up, if required, and then spawns the Ollama processes in the background. Yep, here we go. It manages it like a manager. If Ollama crashes, Ollama will restart it. Okay, yeah. Okay, so my plan is solid, but here is the professional nuance. Ollama bare metal is extremely well optimized for Jetson. Running Ollama Run directly on your OS is fine for learning and general use. It has very little overhead. Docker. In the Nvidia world, Docker is used because Nvidia provides Linux for Tegra base images. Okay, these containers come preloaded with the exact version of CUDA and TensorRT that match your hardware. That's kind of what I was talking about. But I should be able to just mount it, right? Models downloaded by Ollama are stored in specific internal format, usually in this location, okay? If you later want to use a different AI tool like Nvidia specific Docker container, it might not be, ooh, okay, I don't like that. But then we could just like delete that memory or something. I don't know. You might have to download the model again in a different format. Okay. Get the WoW and then main OS clean. Okay, oh, we can just delete it later if we want to clean up our stuff. At this point I just want to run something. I really just want to run something. Okay, so let's go. Okay. Ollama run, and then we want llama 3 and then 8 billion parameters. It's going to pull the manifest. There we go. I'm going to have a glass of water. Oh, hopefully this. Oh, no, I should have done. Oh, no, I should have done this before. It said 3%. I am thoroughly ashamed of myself for not thinking about how much time did I talk just now. Okay. Anyways. Good. Just what we were hoping. Do I have any other questions that I really want to know about right now? Okay. So, I guess what I can do is what are some of the Nvidia specific driver images that I might be interested in the future. Okay, so this is, I'm gonna just see about that. The other thing that we need to do eventually, right, in the next video, not this video, but in the next one, then we're gonna start trying to write a Python script to be able to do orchestration for the Nano, right? So, or for the llama model. Not Ollama. Ollama is the service. Llama 3, that is the LLM. That's like the data, essentially. We're just pulling right now a giant matrix, I think. Right? Like, that's what... I haven't verified that it's a giant matrix, but I think it's just like one giant matrix. That actually might be kind of cool if we can go in and look at that matrix. New idea for next video. But yeah, so in the next video, what I want to do is be able to write a Python script to be able to start interacting with the LLM, not just by saying, like, putting in a prompt, but curating a prompt. Okay, so I need to understand, how do I take in data from the user, be able to curate that, send it to the LLM. I also want to give it tools. So how can I let this model actually perform tools or use tools? Okay. How do you informative all this? That's for the future. That's next video. We're going to learn about it. I don't know how to do it right now necessarily, right? I looked into it a little bit because I was like, okay, well, how is this working? But I don't have like this is definitely how I'm going to do it. So we're going to be making some mistakes in the next video. We're going to be stumbling a little bit, but that's part of the fun. Okay. So yeah. Um, and if you haven't subscribed yet, subscribe, okay? Because we're gonna keep going on this project, and I'm super excited to see where we are gonna be able to head with it, because this is gonna be great. I'm already super stoked about this project. I was so happy when I got it, and I'm just like more and more excited about all of the different potentials which I can do with it, and just learning opportunities to be able to really dig in and explore this space, because it's something that you work with a lot, right? Like Gemini right here, you work with a lot, but how does it actually work? How do these models actually work? Um how do agents actually work? That's something that I was like so confused about, and that is literally the reason that I wanted to do this project, is because I'm so curious about how this world, not this world, but I mean, not the overarching world, but the small world of like LLMs, AI, right? How this system or environment, whatever you want to call it, how it actually operates. And I want to dive into it. I want to learn as much as I can. I want to figure out, okay, well, what's going on? How is it working? How does it operate? I want to know all of it. And so the best way to do it is just build it yourself. So anyways, let's just ask it what I might be interested in the future. Okay, let's see. And hopefully by that time this will finish and we will be able to. Why is it at 64? It's just pause. Okay, so it's at 65 now. Moving into Docker on a Jetson is like upgrading from a toolbox to a fully equipped laboratory. It's normally how images work. Provides several specialized flavors of images through the NGC catalog. Okay, so I can just look this up. It's like Nvidia. I'm assuming I can just like, let's just do it. Let's just do it. Let's see what they have to offer. Okay. PyTorch, CUDA, DeepStream, SDK, software development kit, right? Cosmos, whatever. Highly performant pre-trained what? I don't know. DeepSeek R1. Is this the one that's like, there's one DeepSeek model that's like 100 billion parameters or something like enormous. I don't think I'm going to be fitting that on my device. AI Enterprise. Okay, so Retrieval Llama 3.2. Okay. Neural. Okay. So there's this website that has the different images. Since you're on an Orin Nano, 8 gigabytes is the sweet spot. Here's specific images you'll likely want to use as you grow. So the kitchen sink, the LT4, the Linux 4 Tegra Jetpack. Okay. So this is the most comprehensive. It contains the entire SDK, which is CUDA. What is this? Deep neural network, I'm guessing. TensorRT and OpenCV. Why you use it? If you want to compile a complex C++ AI project and don't want to hunt for libraries. Um, okay. C++. It's like the so when I'm normally doing projects, I build in C sharp. When I'm doing like embedded stuff, I would use like C. When I'm doing AI or like leak code or any of those, I would do Python. But C++, I haven't messed around too much with. So hopefully we'll be able to do everything in Python. Downside, it's massive, often larger than here, which will eat up your SD card quickly. Yeah, yeah. Although this isn't much better. What, 5 gigabytes? Although you can upgrade this um, Nvidia. Man, my brain is really like. um, but you can upgrade this Nano to have a larger memory. Might do that in the future, might not. But anyways, so the machine learning stack ML. So we can do Jetpack or ML for Python developers. Okay, this sounds better. This sounds better. It sits on top of the base OS and includes PyTorch, TensorFlow, JupyterLab, and scikit-learn. Okay. Woohoo! Success! Why use it? It's the fastest way to start a data science project, which again, that's not really what we're doing. We are trying to learn about the orchestration of AI models right now. Later on in the future, that's pretty cool that we have that use case that we could learn, right? We have the capability to be able to jump into that and learn now, but it's not the specific thing which I am hoping to target as of right now. Okay. Okay, robotics, once again, really cool. Not what we're doing right now, but really cool. If you want to, or if you want your Jetson to act or watch, um, Isaac Artos, no, not Artos, it's ROS. Okay, not Artos. These images are for robotics. They use ROS, Robot Operating System, and are hardware accelerated for things like stereo vision and map making. Okay, so you can make a map of your local surrounding based off of the camera feeds which it is observing. Deep Stream. This is for intelligent video analytics. By the way, okay, here it is. Use this if you want to process 4 to 8 camera streams simultaneously. Okay. We can do that. How much more is there? Okay. So Jetson container. Did we just finish that? Yeah. Okay. Technically a collection of scripts by Nvidia engineer. Oh, so this is that same guy, isn't it? Hold on. Yeah, it is. It is. Okay, so he is an Nvidia engineer. Okay, so it is like an official thing. Okay, I'm just always cautious when I go to someone and I'm like, is this an official thing or is it just like, you know, this is the gold standard for generative AI on Orin. So did we download this or what did we download here? This was Jetson contain. Okay, so I did that, and then we pipe that to the sh command, right? So that downloaded this entire thing. Anyways, so we're gonna have to investigate that. I want to understand. Okay, what is this? What did we actually put on our Nano? What was the okay? So script. Which script? I saw one, right? But I see two. I see two scripts. So how does it know which script to grab? I see three. So scripts, and now there's a whole thing of scripts. Look at all that, right? So I want to just dig into this because it's kind of interesting. Like, okay, well, I did this curl, and then from a website and piped that to the sh command. Okay. Which script did it grab? Was it, I can't come here and then go into install, was it? I think it, oh no, I think it was this specific script. I remember install.sh. So it's this script here. So I'm grabbing this script, this exact script, and then just piping this to the sh. So whatever is in this is what's on my Nano. Okay. But right now I'm not going to be able to like dig into this too much, but I want to dig into it in the future. I do want to understand what's going on here. Okay, cool. So a specific container running LLM. Okay, what is this? Nano LLM. A specific container for running LLMs and VLMs with extreme optimization. Okay, Nano Owl used for zero-shot detection. You can type any word, like blue coffee mug, and it will immediately find that object in a video stream without ever training it. Okay, interesting. When you start writing your own Docker files, you'll see lines like from and then the base image, right? Runtime images small meant only for finished apps. Okay. Building apps. Okay, that's fine. Let's do this. Hello, can you hear me? Let's see. It's running. Okay. Hello, yes, I can. Oh, wow, that's really fast. That's really fast right there. I was expecting something like ding, 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 like 1 token per second. That was fast. That was cool. I like that. Um, the other thing is, let's see, how can I help or assist you? Let's just see. What? Let's see. My name is Tim. I want to see, does it have any kind of like memory or something? I don't think so. I think the answer is no. I'm just trying to confirm my understandings of everything. My name is Tim. What is your name? Okay. By the way, this time it didn't like load or anything. It just did it. Is Llama, but you can call me Llama with different capitalizations. Okay, for short. Oh, no. We have one missing L right there. Okay. I'm a large language model trained by a team of researchers at Meta. Oh, hey, it's Meta. Okay. I'm here to help answer. I knew that Meta released one. I couldn't remember if it was Llama or some. Okay. Yeah, so Llama is Meta. Awesome. I'm here to answer any questions you might have, provide information of a wide variety of topics, and even engage in fun conversations with users like you. What would you like to? Okay, so now I'm going to say, do you know my name? What is my name? I'm just going to say, do you know my name? I want to see if it has memory. I don't. Hold on. How did it just have memory? Because from my understanding, an LLM is simply static. It is just a math operation. You put input in, it does the calculations, it comes out. And it's deterministic. You put the same input in, you get the same output out, right? Bing, 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 bing. And I thought if I took away the orchestrator, right? Obviously, that doesn't happen here, but this isn't, I'm not actually interacting with the LLM, the whatever, Gemini LLM. I'm sending my query to Google, and then Google is packaging it up with my previous conversation and sending it to the LLM. That's the way I thought it was. But now this was able to get information about my previous conversation, my previous thing. So is maybe Olama is doing that. Maybe Olama is recording my conversation here, and that's how the orchestration is working. I need to look into that because it kind of breaks my conception of how things actually are operating, which means that there's a misunderstanding somewhere in here. So I need to go into that. I need to investigate it. I need to exit. Oh, okay. Okay. Exit. Awesome. Okay, so there we go. That was a very successful day, and I am super excited for the next video. In the next video, what I am planning on doing is trying to go and write a Python script to be able to start doing the orchestration and actually interacting with the LLM from the Python, and then from that, the user will be able to send data or a request to the Python. The Python is the mediator, and it interacts, it creates the messages, it creates all of those items, which is then sent to the LLM to be the kind of like the reasoning logic side of things. And then we can start adding tools to it and make things cooler and more complex, and just play around with that. The other thing, obviously, as I just mentioned, is I realized that this has memory, which to my understanding, I didn't think that it would have memory. I thought that it was static, so I need to investigate that. So there's a lot of really interesting things that we are going to be coming up to in the next video. So if that is interesting, subscribe. I would love to have you around. And thank you for watching. My name is Timothy Lee Grant, and I will see you guys in the next video. All right, I'm gonna go get something to eat. All right.